indeterminate structures is important. Okay. Basically, if you see a beam, okay, a beam where both end are roller. Okay. So what happens if we apply the load in the vertical direction? It can carry the load. Okay. Now question is that if we apply some load in the horizontal direction, then structure, the beam structure will not be stable. Now structure will move from this position to somewhere here. Okay. Basically, what it is happening here, if the structures is uh, simply supported, okay, that is basically very simply supported. Okay, ideal condition of simply supported condition is that we have one end it is roller, other is that pin connection. Okay, in that case we used to call this simply supported. Okay, now what happened if this is our one case where both end are roller, then the structure become very unstable. Okay, now if you want to make it stable, what we are doing, we are basically what you have to do, at least one end we have to basically hold in such a way that horizontal movement is restricted. Okay, now if you want to make it more stable, what do we do, we have to make it fixed. Okay, rotation also we have to constrain. Okay, rotation also you have to constrain. Okay, we will not allow any rotation here. Okay, now here what we are doing here, you just see once we increase that constraint, once we increase the indeterminacy, okay, in that case structure is becoming more stable. Okay, here also if you see, if we make it both and fixed, and here you can see it is also becoming more stable. Okay, basically what that importance of that indeterminate structure is that a structure become more stable as that indeterminacy of the structure increases. Okay, and second is that it also will work as a backup member. For example, a truss member. Okay, we have truss where there are many members that are connected there. Okay, and in some cases, if a member fails, okay, if a member fails, then indeterminate member that will work as a backup member. Okay, and that member now will carry some load. Okay, basically what it is happening here, basically it is increasing the stability of the structures. Okay, as well as also work as a backup member if some member fails. In that case, that extra member, that indeterminate member will work as a backup member. Okay, so basically a determinate structure, okay, trained to be unstable, static indeterminate or static determinate. Okay, it's a determinate structure, okay, to be unstable. If you want to have more stable, in that case we have to increase that indeterminacy of the structures. Okay, now what is the drawback? If we increase that indeterminacy of the structure, okay, in that case our mathematical complexity will increase. Okay, for a determinate structure only equilibrium conditions were sufficient. So equilibrium means summation of force acting along x direction is equal to 0, summation of force acting along y direction is equal to 0, and summation of all the force, all the moment acting in the xy plane, that is equal to 0. Okay, that if you consider a plane structure, if a structure in the xy plane only. Okay, in that case these three equilibrium was sufficient. Okay, the three equilibrium was sufficient for a determinate structures. Once we increase that indeterminacy, then only this equilibrium condition will not be sufficient to solve that, or to solve the structures, to get all the unknown. Okay, we need to have extra informations. Basically our mathematical complexity, mathematical calculation will increase, okay, for the indeterminate structures. Okay, I hope you got some idea what is that indeterminacy is, how the indeterminacy basically helping us, and what is the drawback if we have a indeterminate structures. Okay, I hope you get some idea. Thank you.